So today what we're going to be working on is combining like terms as well as the distributive property. We're going to start off with combining like terms. You'll notice I use a yellow C, red L, and blue T. And the reason for that is I want you to emphasize like the ideas of circles, lines, triangles, thinking about shapes that go with combining like terms. That's just a method for doing it. First of all, combining like terms is a way of organizing things that are the same to make it easier to do operations, or basically easier to know how many there are altogether. So starting off, imagine you have a huge swimming pool full of snakes, monkeys, and porcupines. Altogether, it's very hard to know how many there are of each of them. So right there, if I asked you to guess, how many monkeys do you think there are? How many snakes do you think there are? How many porcupines? And I use those examples because they're very extreme. As you imagine, you wouldn't want to mix snakes and porcupines and monkeys together. Because that would be a very messed up situation. A lot of snakes would be biting the monkeys and porcupines. The porcupines would be stabbing everyone. It would just be altogether not a good idea. So we can't combine those things. I can't say, hey, I got one monkey and one porcupine. I got a monkey porcupine. I need to somehow separate those things so I can count them. So first off, if I wanted you to figure it out, the best thing to do if I said, hey, how many monkeys are there, would be to put all the monkeys in one pile. All the porcupines in one pile, and all the snakes in one pile. And that's in essence what it is. This is actually the same as was in that pile. You probably would never have guessed correct. I mean, you maybe get close, but realistically, probably not even there. Now, that doesn't necessarily, relate directly to numbers, because when we talk about x's and y's, they're a little bit different. They're not a picture. You can't look at it and see it. They don't stand out as obviously as being different as these do, but they're basically the same. The way I always talk about it to my students is, you can't add x plus y and make something out of that. That's like 2 monkeys and 3 porcupines. You don't put them together and make a monkey porcupine or a monkey snake. It just doesn't work that way. So what we're going to do is we're going to use a visual to help us make them very obviously different, because an x and a y, when it's written in pencil, looks very close to the same. So we're going to use a visual that is something like a circle or a box or an underline, something that will make it obvious to us. So first, when we're combining like terms, we group the terms that are similar. It's the same thing we just did a second ago. So when I look at this, I've got a whole mix of different stuff. And you probably have some strategies. I've seen some people connect things with lines. I've seen some people do different things, rewrite it to where everything's next to each other. That's okay too. And if you already have a method that works really great for you, I'm okay with that. What I'm showing you is a method that I use in my pre-algebra class that I teach to them as the first way they would know how to do it. As a student who's already been in pre-algebra, if you have a great method, you're not forced to use my method. I'm just teaching you one that works for a lot of my students over time. So what we're going to do is we're going to start off and we're just going to make some shape, okay, around all of the things that are the same. So we're going to start with x's just because they're on the far left. When I do this, the most important part is that you want to think of it as a positive or a negative. And what that means is I'm going to take the symbol right next to it. So if I have a minus 2y, I want to go ahead and put that minus sign inside my shape to count it as a negative 2y. So starting off with our x's, we're going to put ovals, circle style things around the x's. That's a positive 3x. I'm going to look here and say, okay, I've got my 2x right here. So now I'm going to go ahead and put the oval around it. Notice I took the positive sign because I want it to be a positive or a negative. The only reason I didn't on the very first one is because there isn't a plus or minus sign in front of it. And at the very end of this problem, we have a negative x. That's like a negative 1x. Okay, now I'm going to just make sure I do a different shape on the next one. So on this one, I went ahead and I used a box. So I'm going to do that around the y's. Notice I put the minus sign inside the box, very important. And then I have an 8y over here on the right side. And I took the positive to make sure I know it's a positive 8. Lastly, I'm going to go ahead and put a third thing and realize you don't have to use ovals or boxes on. It's not like ovals are always x's or anything like that. It's just about giving it a shape to make it look to your eyes really obviously different. And the last one, I just went ahead and underlined. So I underlined all the numbers: positive 7, positive 4, negative 1, and positive 9. One thing I want you to notice, there is not a single number, not a single plus sign, not a single minus sign that is not surrounded and used a shape to contain it. That's very important. If you have any extra plus signs or minus signs, you're not doing the problem right. You're forgetting a symbol you need. And notice as well, now I have 3 different, very obviously different shapes out there. The only thing I'm going to combine are the same things. So, for example, imagine those ovals were the monkeys before. Now I would know, okay, I've got 3 monkeys, 2 monkeys, and then a negative monkey, whatever that would be. But I know very obviously the 3 different things that are going to go together because they're all in ovals. Same for the squares, same for the underlines. So now what I'm going to do is I'm just going to combine. Okay, so in circles I have a total of 3 plus 2, which is 5, minus 1, which is 4. Now let's look at what's inside the boxes. Negative 2y and positive 8y. The great thing about doing it this way is I can do the problem however I want. I can just go 8y minus 2y, which is a positive 6y. It's very important that you put the positive sign in there because these are not treated separately. At the end, we're going to kind of ignore those symbols. In fact, you don't have to write the symbols down at this step. This is just so you guys can see what I'm doing. Basically, you just want to combine the things that are in the same shapes, and you're done with the problem. Okay, and the last one in numbers, 7 plus 4 is 11, minus 1 is 10, and plus 9 is 19. Okay, and like I said at the end, you kind of want to remove those things because you're talking about an answer that doesn't have those shapes in it. People wouldn't understand if you just had that there. That is now the simplified part. What I then have is some people want to make this 29xy. They want to say, oh, 6 plus 4 is 10, plus 19 is 29. You can't do that. Okay, it doesn't work that way. What you do need to do is remember, okay, now I have 4 monkeys, 6 snakes, and 19 porcupines. I can't make a monkey, snake, porcupine thing out of that. Definitely doesn't work that way. Another visual people use will be like 4 extra large sodas, 6 yogurts, and 19 french fries. You're not going to mix that all together in one big blender. Okay, they don't go together. So that is my answer. So at this point, what I want you guys to do is just try one. So I'm going to go ahead and put a problem up here. And I want you guys to pause the video real quick. And on your paper, just give it a try. You don't necessarily have to use my method if you have a really good method that works for you. But if you think that's kind of cool with the shapes, give it a try on your paper. So pause it, hit play when you're ready. Okay, so for me, I'm going to identify similar shapes. I go, hey, I got a 12, a negative 5, and that's it for the numbers. Now I'm going to move along to my W's. Put an oval around those. Now I'm on to my X's. 3 different X's, and I take the symbol in front of it. And because I have a 4th thing, which is Y's, I could put a dotted line, I could put a line on top, just something that distinguishes it. I obviously have color. If you don't have color, it's best to make lots of different shapes. But just don't forget the symbol in front of it. Now I'm going to organize what I have, starting off with the W's. Negative 3 plus 1 is negative 2. I've got my 5x, minus 2 is 3x, plus 3 is 6x. Going along to the y's, there was only one y, so it just stays as is. And numbers, I have 12 minus 5, which is 7. So as you can see, you're just basically going piece by piece. That first step just tells us which pieces get added together. Okay. Again, next problem. Pause the video. Give it a try. Hit play when you're ready. Okay, so one mistake people make here a lot is they think x squareds and x's can be combined. They are different. So if that's something you did, you might want to pause it real quick and try that out. But if not, we're going to keep going on. So first thing, I'm going to start off with my x squareds. I have 3 of them, 1 right there, and 8 at the end. For my x's, I have a negative 9 and a positive 4. And for my numbers, I have negative 7 and positive 6. So now I'm combining. Inside the ovals, I have 3 plus 1x squared plus 8x, which gives me 12x squared. I have negative 9 plus 4, which is negative 5, and negative 7 plus 6, which is negative 1. So if the integer math is the only problem, but you did sort of the problem correctly, then we need just to make sure we remember that we need to have some strategies for that. Okay, and because this is review, I'm going to move on. I'm going to move on to distributive property. What the distributive property says is that basically it allows you to multiply numbers that are added together a little bit quicker. So rather than say, I'm going to take 5 and multiply it times 6 plus 2 plus 2 plus 5, instead of doing it like that, I can go ahead and say that's the same as 6 times 5 plus 6 times 2 plus 6 times 2, etc. And so this is what the distributive property does for you. So first off, let's start about what the distributive property is. What it says is if you have a number outside of parentheses and inside the parentheses the two things inside are added together. Okay, if you have that, then that is the same as taking that outside number and multiplying it by each of the inside things by itself and then adding them together. Okay, so this is useful for a lot of things. A simple example is if you're having trouble with multiplication. So if I have something like 5 times 27, that's a problem I don't know the multiplication answer to. But I do know that 5 times 20 is 100, and 5 times 7 is 35, so I can use that to add it together and figure out the answer is 135. Distributive property is pretty much how we do long multiplication if you really think about it. Okay, so how do we use this? So here's an example. Now again, I'm going to go back to the way I teach my pre-algebra students. As an algebra student, you may very well have done distributive property, and if you have a slightly different method that works just as good, that's okay too. But what I teach my students is to do is when you notice that number outside the parentheses, that tells you distributive. At that point, you're going to go ahead and first circle the number outside, including any symbols. So if it's a -2, you're going to circle the negative sign. Then I'm going to multiply that by both of the inside numbers. And the nice thing about this is you use these arches. Okay, and the purpose of that is what it does for you is you should have 2 arches. So however many things are inside the parentheses, you have an arrow that points to each one, and it reminds you that you need to write those down below. Okay, so first I had the 2 times x, then I had the 2 times the positive 3 inside, which gives me 2x plus 6. Okay, so the last step is to simplify, and you get 2x plus 6. Now, if you're comfortable with this and you want to skip this middle step here and go straight to that answer, that's fine. It's nice to have it written out, though, in case you forget a piece. What I notice a lot of students do is they'll give me 2x plus 3, which is basically they remember the 2 times x, but they forget the 2 times 3. Let's look at another example. Go ahead and pause the video really quick and give it a try. Okay, so what I would recommend you do is you circle the outside number, including the negative sign, and multiply each piece. That's going to give me -6x, and that's going to give me -3 times -1 is positive 3. And the reason I have that plus sign in the center is just to remember that you're multiplying a negative times negative on the right side. So I end up with -6x from this part being multiplied, and -3 times -1 is positive 3. Okay. So moving along, the next thing we're going to look at is the reverse distributive property. What that means is we start with only having 2 things. Okay, so it's basically you start with it already being multiplied together and you're trying to go backwards and create a problem where there's a number outside of a parentheses. So let's look at an example of what that looks like. We want to go backwards and we call this a factor. The reason we call it a factor is because factors are always multiplied together. So we're going to go backwards and create 2 things that are multiplied together. The best method for doing that is to use a rectangle, okay? And the reason for this is we're going to actually use something similar to this later. So if you can practice this now, it's a great way to do it. So we're going to take this and we're going to place inside of it the 6x and the positive 9. Okay? And this works very much like a Punnett square that you'll learn about in biology this year, but sort of a small version of it. And what we're looking for is on the left side, we're looking for a number, the largest number that will divide into 6x and 9. We want the biggest number we can find. So think about that for a second. So here's a strategy that I use. Start with the number you already have. Does 6 go into 9? No. Now work your way down. Next thing I can think of is 3. Does 3 go into both? Absolutely it does. Okay, because of that, I know that a 3 is going to go on the outside. Now all I have to think about is, okay, if that's the case, what would go right here? Well, what do I multiply 3 times to get 6x? Well, I know that 3 times 2 is 6, and I need this x to come from somewhere, so it must have been 2x. Similarly, if in order for this to be a 3 and that to be a 9, I would have to have a positive 3 up here as well. Once you get to there, you're not quite done. All you have left to do now is write it as parentheses problem. 3 parentheses 2x plus 3. Whatever ends up on top goes inside the parentheses as if there was a parentheses on each side, and the number on the outside on the left goes outside the parentheses. So let's give this one a try. Go ahead and pause the video and give it a try. Notice that this is a negative 12 here, so you're going to have to take a negative out of the problem. Alright, so we start off with our square. Inside we have a negative 12 and a negative 4. As I said before, if this is a negative, you have to take it outside. And the biggest thing that goes into both, in this case, is negative 4. Okay, in order for this to be negative 4 and this to be negative 12, this up here would have to be a positive 3x. And over here, I need the positive 1 to multiply and create a negative 4. Last step, write it as a parentheses reverse distributive property problem. Okay, so now we're done with our video. What I want you guys to do is take the survey down below so I know you watched the video. And please, please, please leave any questions for me that you need clarification on. Try to answer the couple of questions so I understand that you get the process of this. And leave me anything under the part that's still confusing. And I will see you guys in class soon.